Hello, I'm Dave Israel from the NASA Goddard Space Flight Center. I am the Exploration and Space Communications Projects Division Architect, and I'm also the Principal Investigator for the Laser Communications Relay Demonstration. And today, I'll be giving you highlights and an overview of NASA's Laser Communications Program. So LCRD is the Laser Communications Relay Demonstration. So it is our latest mission in the series that we're doing to infuse optical communications or laser communications into our missions and systems. So the reason why we're pursuing laser communications is that though we've been very successful and have over half a century of experience and success transmitting data to and from space using radio waves or RF radio frequencies or RF links, there's physical limits that just make it impractical to use RF to get the high data rates and the high data volumes that we know we're going to need for future science and exploration. So, optical won't replace all of the RF links that we have, but it will be the way that we get our high data rates to and from our space missions. And it's really critical for us to get the experience that we've acquired over the last 50 years for RF. We've learned all the ways to make the most out of the technology operationally, but we don't have that experience for optical communications. So LCRD will have 2 years on orbit for us to learn and get that experience so that we can infuse this technology and use it operationally. So go to the next slide, please. So laser communications, because of the physics of changing our carrier of our signal from RF frequencies to shorter wavelengths, or you can view it as higher frequencies that move in the electromagnetic spectrum. What that does is first that higher frequency allows us to modulate the signal to make it possible to carry higher data rates. And when you combine that with the ability to focus your power much better with the smaller apertures, you get the laser beam essentially. Then the combined effect is that we can send orders of magnitude more data over the links, and we can give the same performance at the same data rates with a much smaller swap or size, weight, and power terminals or systems on both the spacecraft side and the Earth side. So when you bring those two things together, that's what really makes it possible to get those higher data rates that we're seeking from the greater distances that we want to go. So this video shows the laser communications relay demonstration. So this is a payload. So what you just see there is the payload that's on board the STP-SAT-6 spacecraft geosynchronous orbit. So STP stands for the Space Test Program. It's a Space Force satellite, and LCRD is a payload on board. You see the payload there. Right now, what we're looking at are the two optical terminals or telescopes. So these are the things that actually move and track between our two endpoints that we're communicating with in the start of our mission. Then it'll be pointed at two ground stations. We have one in Haleakala, Hawaii, and the other is in Table Mountain, California. Though those optical modules are built to be able to track things in low Earth orbit, so that one will be tracking to stay connected to an orbiting user, while the other is pointed down to the ground station. And the electronics that you see on the top part of that panel are not just the modems and the electronics for the optical links, but there's also a switch unit that allows the data to be connected between the two, and that's what allows the relay of an optical to optical relay to happen. So in the beginning, we'll be communicating only with the ground stations. But if we go to the next slide, you'll see our plans to add an orbiting user. on the International Space Station. So there's the Illuma-T, which is set to launch in 2022, and that is an optical terminal that will go onto the space station. It'll allow LCRD to demonstrate that our everything that was working when we were relaying between two fixed points on Earth will also work while we're communicating to a user in low Earth orbit, while then also we'll be able to demonstrate user terminal equipment on the space station, and we are working to evolve the system into capability to provide more data throughput to and from the space station as well. So LCRD follows the very successful LLCD mission that flew on LADI in 2013. That mission proved the technology, but LCRD is what allows us to go farther. Now that we know that the technology works, now the question is how do you make the most of it operationally? And that's what our 2 years on orbit are to do various experiments and demonstrations to learn how to make the most of the technology. Also coming up is the T-Bird mission. That's a small set that's going to be carrying a laser terminal that will allow us to transmit 100 to 200 gigabits per second from low Earth orbit straight down to a low, potentially low cost or a small optical ground station. And so this would be a huge game changer to allow things like Earth observation satellites to collect data, fly overhead, the scientists' home university, perhaps, where there's a small-sized telescope tracking it, dump a whole day's worth of data, right there in their backyard or the top of their building. So that's a huge game changer there. We are working to put optical onto the Artemis 2 mission. We're soon to deliver that terminal, and this will be the thing that provides the link for the HD video, so that we'll all be able to watch the first time astronauts go back and orbit the moon and are in the vicinity of the moon. And then there's also soon to launch the DSOC terminal, which is a Deep Space Optical Communications project that will be our first time to really demonstrate the ability and the challenges to communicate way beyond the moon using optical comm. It's going out to the asteroid Psyche, and will demonstrate the ability to overcome all of the challenges that the true deep space optical will face. The next slide, please. So the planetary laser comm is certainly one of the main drivers for us to use optical comm. There's the science objectives, even before you get into human exploration, just to try and get high resolution pictures of Mars or any place you want to go is just going to generate more data. And the only way to get that data back practically is to use laser communication. So though LCRD is in geosynchronous orbit, it's already above the clouds and the atmosphere. So what we learn on LCRD to operate through those situations will apply directly to the planetary situations, and then also some of the networking and ops concepts that we demonstrate will also apply to the planetary situation. And then, of course, once we're flying DSOC, then we'll get more experience from a genuine deep space optical terminal. So next slide, please. So for the lunar exploration, we've been developing something that we call LunaNet. So this is to basically provide the equivalent of the user experience that we have here on Earth with our mobile networks and our cell phones, where there's communications and navigations and everything all brought to a user terminal and an infrastructure that can support it all. So on Earth, there's the transatlantic fibers that interconnect Europe and North America. And so we have all of our data connections, and some of our data flows all stay in the U.S., but there's some data that's headed off the continent, and it gets aggregated somewhere, goes onto a laser communications link, but put onto a fiber to get across the Atlantic to Europe. So in that same sense, for LunaNet, then there'll be relays that will be the equivalent of those transatlantic fiber stations that will connect the lunar communications to a point where the data can be aggregated, and then instead of an intercontinental connection, it's an interplanetary connection, and we can't string a fiber all the way to the moon, so we have to do free space optical communications, and that's how LaserComm will fit into the LunaNet. And my last slide. So there's a lot more information available online. So I encourage everybody to follow these links. There's more detailed information ranging from updates of how all these projects are coming along, but there's also a lot of STEM material suitable for all age groups to help to really understand the concepts behind laser communications. So this is an exciting time as we now are coming upon the launch of these missions that I just described. So we are very excited to be at this point in history to see this working and infuse this technology.